Anyway, we can skip past the memes. So today is kind of like, honestly, hopefully it's a little bit of review and kind of waking up your brain a little bit. So we're doing all the different types of numbers. So like the natural, whole, integers. I have like stupid ways to remember it, so you can just kind of go with it, or if that helps you, great. If it doesn't, that's fine too. But like natural numbers is like, I think of like a normal person talking. So like if you were asked to count, you would start with one, like 1, 2, 3, 4, 5. So like how you like start counting. So see, this is what I mean. It's gonna drive me nuts. Sorry, there we go. So normal people counting. Okay, whole numbers is the natural numbers and 0. So like the way I remember the whole numbers is like the word whole has an O in it, so it's like 0 in it, Okay, so natural and whole. Natural is normal people counting. Whole is like has the 0, 1, 2, 3. Integers, I don't have a funny thing for that. Integers is like all the whole numbers and their opposites or their negatives. So 1, 2, 3 and negative 1, 2, 3, including 0. Rational numbers, think of like ratio. So like ratio means fraction in like math world. So rational numbers are all like the fractional ones. So like the ones that people get messed up with the rational are like these, like the decimally looking ones, because everyone can see a fraction and be like, oh, duh. But like the ones that repeat, or like 9.3 repeating, or like 4545, whatever, or terminating. Because you could technically write that as negative 34 over 10. Like you could write it as a fraction. So like decimals that stop or repeat are rational, even though they don't really look like a fraction. That's what they are. Irrational is like the ear part of it means not. So it's basically if you tell something is a not rational, you're going to say it's irrational. So those are like your pies and your root 2s and 3s and like the crazy decimals that have no pattern and just go on forever. And then real numbers are like all the things. So real are like all. And you would be like, why do they have a name for it? So in Algebra 2, they actually talk about imaginary numbers, which is like kind of psychotic if you think about it. But they're used with like vectors and physics and stuff, more for computing things, but not whatever. So the first like questions on your quiz and your test is like naming like which one it belongs to. So it could be more than one, which is what makes it like harder. So what I do is I look at like the most specific and then just kind of like go out. I think that makes more sense in my brain. So for 15, I first think like, would a normal person, if you ask them to count, say the number 15? And I think they would. So this is a natural number. It's like 1, 2, 3, 4, 5. If you kept going, you'd eventually hit 15. So this is natural. If it's natural, you can kind of cheat if you want a little bit, because if it's natural, it's going to be all of these. So like wherever you are, if you're more a visual person like I am, I like this thing because then you can just kind of like start writing them all without thinking much about it. But natural is like the most specific. So you're going to go natural, whole, integer. Then we've got rational and real. So this one has like all the things. So that's what I usually do. I'll like start like, I think like this Venn diagram helps me the most. Like start at the most specific thing and then you work outward, because everything's going to be real in this class. Okay. So we'll try this one, then you can try the other one. So negative 3/5, like a person counting, like when you're in kindergarten, you're not going to say negative 3/5. You'd be like a weirdo child. So naturals, no. Whole, no. Integer, no. This one is a fraction, looks like one. So this one's rational. And you might like freak out because it's negative, but it's, that doesn't matter. The positive and negatives for rationals don't matter. I didn't say that before. But rational, so again, if you're working outward, rational, then the bigger picture is real. So you can kind of cheat and put real for all of them if you want right away, but that's what it's going to be. And then C, does anyone have an idea what that one is? Or one of them? Yeah. What? It's not like 7 would be, -7, but the root 7 like messes it up. So it's not integer, but that's a good guess. Irrational. Yeah, irrational because of the root. So if it was plain -7, absolutely integer. And this one's kind of, okay, so that one may have thrown you off. That one, if you would reduce that, that would be 7. So it ends up being an integer. So that one's kind of tricky. But root 7 doesn't turn into anything nice. So we're just going to write irrational. Okay, so that's, oh, and real. I didn't write real. Whoops. There we go. So yeah, I would just do that. Is there any questions on those? Okay. This one is rounding. So rounding is as far as, this is like the place value chart, right? So if you're doing wholes, that's to the left of the decimal point, parts are to the right. It doesn't start with once. That like sounds weird. Okay, so it's always tenths is like the first spot. Then hundredths, thousandths, 10,000ths with the th. Be careful because especially on multiple choice, people aren't reading it like close enough, you know? So like for A, like this is just some rando, they say 10,000, but then people would want like, they would do the 10,000ths place. So just like be careful. So like when it's in D at the end like that, 1,000, that's like your whole numbers, like no anything after the decimal. So like if you're doing 10,000, this is, see? Yeah, so this is like ones, tens, 11, or hundreds, thousands, 10,000. So you're going to be looking here. Maybe I'll write this over so we can 5. Get that? So 10,000 would be this number. That's either going to stay the same or change. So the way you're going to look at it is you're going to look at that number to decide whether it stays the same or goes up. So for that one, yeah, it's going to be 330,000 would be rounding to the 10,000. So it's that number is either going to stay or change. So this is going to be 327,596. So you look for the hundredth spot. So again, you're looking here for the hundredth spot, and then that's either going to stay a 5 or go up. So that means it's going to go up. So 327,600 because the 9 round to the nearest. So 5 and up you round up, and then 4 and down you're keeping. And then the 10. So this one is where people get weird. Is this one? I know I keep rewriting the numbers here. So if it's the 10s, you're going to be looking at the 9. Okay. And then the 9 is either going to stay or go up, which is going to be weird. But like, since this is a 6, it means you're going to round the 9 up, which it's like you don't have anything more to go. So what you're going to do is actually round up the hundreds place. Okay, so this is going to be 327. And then the 9 turns to like a 0 because it's like 10, you know? But then that 10 carries over to the hundredth. So that one's kind of like the weird case. Yeah. So that's the tens place. Okay. Then these are just using now the decimals, kind of. Okay. So thousandth, th, that one's not, right? So you just have to be really, 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 really careful when you're doing these ones. So 72463.368. I don't really like, my handwriting seems worse on here. That's okay. Okay, so thousandth. So remember, this starts at tens. Okay, so the 3 is tens, 6 is hundredth or hundredths, and then thousandths, you're going to be looking at the 8. It's either going to stay in 8 or go up. So because of that 2, it's going to stay in 8. Okay. Is your brain kind of waking up? Hopefully. So that would be your answer. And then why don't you guys try the last 2 and we'll see if you can get it. I'm going to freeze this. You guys can check with your people, see if you get it right. Okay. Hey, does anyone know B? 3B? 3B? Did we get it already? A lot of you have written down. What'd you write? Do I have to do sticks? Do I have to do this? Talk with your people, or do you got it? Here, go ahead. It's just 0.4. Yep, 0.4, and then 1,000. Doesn't stay the same. It's a good guess, though. What do we think? To the nearest 100. Oh, you guys, you're like the shy people. How about talk with your people? I'm going to call on a rando. So you have a group representative. Okay? So talk with your people. What do you think you got? And then I'm going to pull a rando. Plus, I don't know anybody's names yet. Okay, you talk with your people, right? I'm pulling a rando. I have to remember where. Oh, yeah. Doing the sticks. Just kidding. This one's not in my class anymore. Nope, she's not here. This is not working well. I have not done sticks in so long. I know. No one's talking. You guys all have the same answer, right? Oh my gosh, I gotta change these. You guys are all freaking out, hey? What is this? Okay, Deanna, what'd you guys get? 572,000. Yes, exactly. Perfect. Here, wait, I wrote the wrong number here. Here, froze. Here we go. Okay, so it's the 4 made the 2 stay the same. Okay, good? All right. Now these properties, last thing, again, I have stupid ways to remember, so you can remember it or just ignore me, it's fine. But there's commutative, associative, distributive, identity, and inverse, and then you say addition or multiplication. So it's kind of annoying to write. The only one you don't have to is distributive, so at least there's a silver lining. So this is my stupid ways, okay, to remember it. So just go with it. So commutative, it's basically means like you can change the order of the numbers and it won't matter, like for adding and multiplying. So you could go 2 times 3 or 3 times 2. It like doesn't matter. Commutative, see how there's 2 M's? You can switch around the M's and it won't matter. Okay. So if the M's change, it doesn't matter. The word's still the same. So that's how I remember commutative is the switching. Okay. Associative is like, if you're adding like 3 numbers together or multiplying 3 numbers, it doesn't matter the order you add them. Like if you had 1, 2, 3, you could add 1 and 2 first, then 3, or you could add 2 and 3 first and then 1. So I think because it's like got parentheses, you can be like, I can associate with these friends or these friends. Okay? So think of friends. Associate with these people or these people. I don't know. Just go with it. Okay. Distributive, I feel like you've heard a billion times. That's the one where you like multiply it to the sum, So distributive property, I think you might already know. Identity and inverse is like, oh my gosh, they always get mixed up, right? So identity is like, it's what, oh my gosh, this thing's crazy. Okay. It's like, what do you like? An identity is what do you add or what do you multiply to get the same number back? Like you want yourself back. I don't know, it's so stupid. But like identity is like yourself. So like if you add 0 to anything, you still get the same number. If you multiply by 1 to any number, you get the same number. So identity is like you're getting yourself back. I don't know. Just go with it, okay? Inverse property is like what do you try to do to get 0 or 1. And for inverse property, you do this all the time with algebra. This is like your algebra stuff. Okay, so inverse is like, you know how you like add to both sides to like cancel out something or divide both sides to get like 1, to get it alone, to get x alone. You're using like 1,000 inverse properties, okay? All right, so then this one, you have to like remember all the names, which can be hard. So naming the properties. So like notice this one, they just switched the order. So just like the M, you can switch the M's and it's still the same answer. So you're going to say I'm afraid to do this thing. Commutative property of, and then you have to say if it's addition or multiplication. You're like, how do I know? Because there's addition in it. So this is super annoying. So if you took geometry, you've already been in the struggle. So that's what you do. And then B, again, it's a bunch of parentheses. So like usually I'm between associative or distributive because it's got like a ton of parentheses in it. But yeah, it's just kidding. It's not because there's weird equal signs in there. That's a plus. Just don't look at it. So that was supposed to be a plus, but this would be associative property. You can abbreviate property of, what is it, adding, addition. Okay. Okay, so here's like another parenthesis thing. So you're going to be like, okay, what do I do? Well, the parentheses aren't on the other side, so that might help. What they did, they wrote it kind of weird, but they did do the distributive. They like did 3 times 5 plus, here, maybe like if you, that's going to be confusing. It's like they did 3 times 5 plus 3 times 2. They just distribute it. And that one you don't have to write like addition or multiplication because it involves both. So you just write distributive property. And then this is the one where everyone messes up, is this identity or inverse. So what I do is look at what it's equal to. And you have to decide, is that the number I started with or is it like a 0 or 1, right? So this one is the inverse one because you're getting a 0. So this is inverse property of addition because you're adding. And then these guys, there's questions like this on the test and quiz where you have to name it. So there's an additive inverse and a multiplicative inverse. So inverses are where you want it to like, whenever it's like inversing, you want it to equal 0 or 1. So for adding, you want it to equal 0. For multiplying, you want it to equal 1. So inverse, so identity, think yourself. Inverse, you want it to equal 0 or 1. So if it's negative 2/3, you want to figure out what do you add to it to make it 0. So that would be a positive, right? Multiplicative. Does anybody know that one? Do you remember this with fractions? Any idea? Like, what do you multiply that to get 1? Yes, but they would look really ugly. This one particular would look ugly. This is not technically wrong, but it wouldn't be like an option on multiple choice. Because that's like icky, you know? Like kind of crazy looking. But it's right, technically. Does anybody know? No, because that would give you positive, what would that be, 4/9. We're going to do more stuff with fractions later too. It's reciprocal. Do you remember that? So you would do, it would still be negative because you want it to be positive 1. So it would be negative 3/2 would be the answer. So again, this isn't like wrong. It just looks goofy. You know, like it wouldn't be an option on multiple choice. Like marked right if it wasn't multiple choice? No, I'd like you to get to the negative 3/2 because we're going to do stuff with it later. So, all right. That's it.